Okay, so what D is asking is that it says the density of the bacteria in the petri dish for R equals 1 to 4 is modeled by a function G. For what value of K between 1 and 4 is G of K equal to the average value of G of R on the interval 1 to 4? So you're given G, okay? Basically, it's saying when is G equal to the average value of it? Okay, for what value is this equal to the average value? And we've done problems like this throughout our nooks. So first, what I want to do is I want to find the average value of G. Okay, and so that's going to be 1 over B minus A, 1 to 4, G of R dr. Now, let me tell you something. G is a function that they gave you, right? So it's defined. We all know what G is. They know what G is. You don't have to tell them what it is. It's fine to just write the integral and just reference G of R like that. You don't have to write in the actual function. So now we have to do this on the calculator. So go ahead and take out your calculators. You have to be super, super quick with plugging things into your calculator. Whenever you have to work with things like this, what I would do is I would, put it in the graph, right? So let's put that in the graph. So this is 2 minus 16 cosine of 1.57 root R or X out here cubed. Is that the correct function? Yes, right? Enter. Huh?
You need the parentheses around the cosine.
It is around the cosine. There are 2 sets of parentheses. Okay, so look, and always be careful, that you look at that. Look, there are 2 opened, 2 closed, and here 2. And then if you like, so this is from 1 to 4. Fine, I'm just going to leave it like that for now. So I put that in there. But what my integral says, okay, I'm going to go back to the home screen. What I need to find now is 1 over 3 times the integral, okay, and do this using the tab, 1 tab, 4 tab. Here, recall it from the graph. So f1 of x dx. Okay? Enter. That's that. Okay? So here we're going to say that this is 9.87579. Okay, this is an intermediate step. So I went to, a couple more decimal places. Okay? Now, what my question is asking is when, so remember on my test, I would say, and now state, when does the function assume this value? That's what we're asking now. When does the function assume this value? But I was nice. I split it into part A and B. They're not doing that, okay? So what we have here is this, right? So look at what I do. I go over to that, okay? Now you can do Control C, okay? Go back in your function. You want to know when is this blue function equal to that value. So press tab. In F2, do Control V. Enter. Okay. Well, what was that? It was like y equals 9.8, right? I need to see. Look, you can do a couple things. You can go on any white portion of the graph, of the grid, press the center button and grab it and just drag down, and you can move the screen wherever you want. Okay? So look, there's where the points intersect, right? The graphs intersect. So menu, analyze graph, intersection. Oh, look, it's at 2.497. So I say, okay. So let's see what we're going to write. We're going to write down G average is equal to G of K at K equals 2.497, standard 3 decimals over there. The other location is not in the domain, so I don't need to worry about it. Okay, that's at 5.8, not in my domain, don't need to worry about it. Okay? Questions? Yeah.
I have a question. Are we going to be getting like homework schedules for these couple weeks?
The first two are calculator, okay? And then the other ones are not. You'll see. Right. So you see how here it says section 2, part A, 2 questions. And these are calculator required questions. So this was number 1. Now we're going to do number 2. And you see after that, the ones that are coming up, they're not calculator. Okay. 6. Okay. So 15 minutes per. Okay. A particle P is moving along the x-axis. The velocity of particle P at any time t is given by this for t equals 0 to pi. At t equals 0, particle P is at position x equals 5. So that means x of 0 is equal to 5 for particle P. Okay, so I drew a little subscript. A second particle Q moves along the x-axis. The velocity of that particle at any time t is given by this in the same time interval from 0 to pi. At t is 0, Q is at position 10. So initial position for Q is at 10. Right, and all those times, right, where I told you, you gotta label things so you can keep track of your functions. This is what I was talking about. When you find something, a quantity, you have to label it so you can keep track of it. Okay, find the positions of the particles of P and Q at t equals 1. Okay, well, let's see. So part A. So I want the position of P at t equals 1. Okay, now remember, this is final position. And how do we find final position? Well, it's initial position plus the integral. And this is going to be Vp of t dt. Okay? Now, whenever you do ones like this, this is the initial position at t equals 0, right? So you have that, you have the initial quantity at t equals whatever, then the integral starts at that same value and, you know, to another value, okay? And it could go from 0 to moving forward to 4 to 1, or it could go from 0 to like -3 in another situation. But basically that point and then that point repeats. Okay, so this one you're going to do with your calculator. So go ahead and let's plug these into your calculator. The easiest thing for me to do here is maybe to clear the scratch pad so I can start all over. Okay, so click on where it says scratch pad. It'll give you a drop down menu and it's the last one, or B. Okay, so I'm going to put in V into here. So that's going to be sine of, what is it? T to the power of, so x to the power of 1.5. Okay? And you know what? Let's just go and make the window from 0 to pi. All right, it doesn't take that long. Okay? So that's the region. And then, all right. So, whoops. Okay. So basically, let's do this. So x of 0 is 5. Whoops. Plus, now I need to find the integral of this from 0 to 1. So I go to the home screen, and I want to do the integral from 0 to 1, what am I going to write in here?
That's a 1 of X.
And that's 0.37066. So together, that's 5.371. That's x of 1 for P. Now we're going to do it again for Q. That's the initial position at Q. Yeah, plus 0 to 1. VQ of T dt. And when you do have two different functions, they're really going to look for a consistency of you labeling them properly. Okay? So what do we get here? Okay, so here's what we're going to do. This is 10. Now, look at what you're going to do. You're going to go in here, tab. In F2, let's put in the other one. So that's 1 minus 1.8. No, sorry, that was.
I got a negative number.
Yep, that's fine. 1.25 to the power of T.
Yeah, why did I get a negative number? I got negative 1.4356. As the
Yeah, that's fine. That's fine. Because look, the other velocity is down here, right? So now, look at what we're going to do though. So that's second velocity. I'm going to go back to the home screen. I'm not going to retype everything over again. I'm going to go up, select that, press enter, and then edit and make it a 2. Okay? So that's negative 1.4356. So that's 8.564. And this will give you full credit because you've labeled everything. 3 decimal places. You've shown everything. Good. Okay. Part B.
When you're actually,
Yeah.
I was saying when you're
Yeah, I
subtracting,
got
should
that.
you
Okay, that's fine.
round it to the thousandth, or does it not matter as long as you round it after?
Wait.
Like here.
No. Do 10 minus. So when you put it in your calculator, I wouldn't round at all. When I put it in my calculator.
No, I know. I'm saying when you do 10 minus what you've got, should you do a bunch of values and then round after that, or round before you subtract?
Okay, so look at what I'm going to do. You're going to do 10 plus, you're going to go up here, select that, and do the whole thing. Or you're going to do 10 plus the answer. Never round before. You only round to have something to write down on paper to show them the intermediate step. Okay, so next. Are particles P and Q, okay, I love this question. Are particles P and Q moving toward each other or away from each other at time t equals 1? Well, let's see. How do you know?
Because
Actually, no, they are same value.
the function of P is getting bigger, and the function of Q is decreased as time moves forward.
Q's initial is greater than the
So here is how we need to figure this out. At t equals 1, right? Or I'm sorry.
At t equals 0, it's at 5 and 10. So then at t equals 1, it's 5.371. So t is greater.
Okay, so at t, okay, so that's a good way of saying it as well. That's a good way of saying it.
That's what I'm trying to
I see what you're saying. Okay, I see what you're saying now. Yes, okay. So what Emmy is saying is this. This is P and this is Q, okay?
Yeah.
What Emmy is saying is, at t equals 0, P was at 5, now it's at 5.3. This was at 10, now it's at 8. So clearly they're moving towards each other, and that's the reasoning. Absolutely, that's it, okay? You can explain it like that, right? What we're gonna do, however, is we're going to say, okay, so at t equals 1, the position at 1 is 5.371. So you also have to show that at that point, it's going to continue moving in the right direction, right? Or to the right. So if you look at the graph here, this is the blue one is the velocity of the first one. The velocity is above the x-axis, meaning it's got positive velocity. So it's going to continue moving to the right, okay? So, and Vp of 1 is greater than 0, which means it's moving to the right. Okay? Now, at t equals 1, q of 1 is 8.564, and VQ, I did that. X of Q. And VQ of 1 is less than 0, so it's moving to the left. Okay? Right? Because the red one is underneath the x-axis, so it's moving to the left. That means, since one is going to the right, the other one's going to the left, they're moving towards each other. So therefore,
How do we know the velocity is less than 0? I lost you there. Is that based just on the graph?
yes, because the graph is the velocity of q and it's underneath the x-axis. Okay. All right. So the story is different towards the end, right? Because now, well, what's going to happen? Now they're going to pass each other, and one is going to they're going to be moving in opposite directions, so they're moving away from each other, right? So they're moving towards each other. Then at that point where they intersect, they're at the same, right? Then they're going to Therefore, P and Q are moving towards each other. Okay, part D.
So if one is moving right and the other one is moving left, that's how you know them.
No, not necessarily. Not necessarily, because if this is moving left and this is moving, like if they were moving like this, then they would not have been moving towards each other. But specifically, this one is moving to the right and this one is moving to the left. That's why they're moving towards each other.
Right.
So it depends on their position and the direction in which they're moving. Okay, so part C. Find the acceleration of particle q at t equals 1. Is the speed of the particle q increasing or decreasing at t equals 1? Okay, so two things here. First, we need to find the acceleration. So for part C, you have to say this. You have to say acceleration of q at 1 is equal to v prime at q of q at 1. Okay? That's all you need to write. And then the rest you do on your calculator and you say, well, you can do it here actually, right? All you need is the derivative. Menu, analyze graph, dy dx. Which graph? This graph. Position, you can just type in 1, enter, and there we go. That's the velocity. I'm sorry, that's the derivative. So it's 1.0269.
How do we explain? I personally have on the display. How do I get that? How do I make that?
I don't think it'll work like that.
It does look like that.
It does? Okay.
It gives me to the 10,000.
If you press plus?
Yeah, if you push plus right now.
Oh yeah, so just press plus.
Stevie, look at you.
Okay. I mean, it does work. When you find points of intersection, it doesn't work. You have to do it through the menu, but these work. Okay.
How did you find the...
Okay. So that's the acceleration. Then it says, is the speed of the particle increasing or decreasing? Meaning, is it speeding up or is it slowing down? Okay? And how do we figure that out? Right. So we say, since the acceleration at 1 is greater than 0, and the velocity of q at 1 is less than 0, therefore, the, what is it? Speed
I got 8.10.
is decreasing. You may have done it on the wrong graph. Did you do it
I
on?
only have one graph.
Need to find the total distance traveled by particle p over the time 0 to pi. Well, this we know how to do, right? So total distance is equal to the integral from 0 to pi, absolute value of Vp of t dt. Okay, now let's pause here for a minute. As far as work is concerned, this is all you are required to show. However, if you didn't explicitly state Vp, if you just did V of t, that might get you into trouble. Okay? Right. So now there are a few ways it could go. Now the correct answer here is 1.931. So suppose you didn't put the p, but you got 1.931 correct. Depending on like the way that particular question is graded that year, you may or may not get the point. However, if let's say you put 1.93, okay, that's not even, so that's the right number, but not the correct decimal place. So if you put 1.93, you're not going to get the answer point. And if you only did V of t, you might not even get the point for that. You see that? So you have to be very, very explicit, very, very careful, very, very clear. Go. So here we go. Next, you have 4 questions and no calculator allowed. So the way it'll work is you will seal, the test for part 1 and questions 1 and 2. You seal it, and then you can start on this one. So there is no way to go back to the other part. And of course, you have to put your calculator away. Okay, so a company designs spinning toys using the family of functions given here. Okay, let's talk about this for a minute. Where c is a positive constant. Let's talk about this for a minute. You've got square root of 4 minus x squared. If you just look at square root of 4 minus x squared, what shape would that have given you? A semicircle. But now you have that multiplied by an x. And x is a linear function. And do you see how this is like the compromise between a semicircle with like a linear function infringed upon it? Do you see how cool that is? Okay. Yeah, and also like y equals x is in this part of the grid, right? So it takes more effect here than on the other parts. Like, do you see? Okay. The figure shows the region in the first quadrant bounded by the x-axis and the graph of this for some c. Each spinning toy is in the shape of the solid generated when such a region is revolved around the x-axis. So you put in different values of c and you get the same shape but like bulged out differently. And when you rotate that, you get a solid, and that's how you get like the different spinning toys of different shapes. So now, tell me again, where do you use calculus? Right there. The guy who designed that, right, who sent it to the like woodworking machine to carve out that spinning top, used like this is how it went. Like there is not some old like woodworking person sitting in the bag and like, like shaving off wood to make these toys, right? Okay, so first it says find the area of the region in the first quadrant bounded by the x-axis and the graph of this for c equals 6. Okay, so, okay, what I need to know is what these values are. Okay, what are the x-intercepts for this function? So before I do anything, let's find the x-intercepts. So you're going to take your function, which is c, well, it doesn't matter if you put in the 6 for c, right? Because it's going to go away. So cx 4 minus x squared is equal to 0. So x is 0, x is plus or minus 2. That means this goes from 0 to 2. Okay? I have done no calculus here. I just used algebra to find the x-intercepts of that function. Cool? Cool. Now let's find the area. So, what's another word for area? Starts with an E, it starts with an I. Integral. It's the integral from 0 to 2 of 6x 4 minus x squared dx. Okay, this is the non-calculator section. It means I'm going to do this by hand. Yeah. Okay. So, good old U substitution. Du is negative x 2x dx.
Let's say negative 2 is
0 to 2. Okay, so now this is going to be the integral, the square root of u, okay, fine, the square root of u. Now what do I have left here? 6x dx. 6x dx, is that negative 3 times this? It is. So negative 3 du. Okay, let's put in the new u's. U at 0 is 4. U at 2 is 0. Okay, so now there is a little problem here because my limits need to change, right? So I have to multiply by a negative. So this is going to be positive 3, 0 to 4, u to the half du. Okay? Got to change the limits. So now this is going to be 3 times u to the 3 over 2 times 2/3 from 0 to 4. So this is 2 times 4 to the 3 over 2. Okay, so that's 2 times root 4 is 2, cubed is 8, 16.
Wait a minute, I lost the part. Why did the zeros change from 0 to 4?
Because the limits have to go from lower number to greater number, so you have to change the you have to like flip the integral around.
There's a way to do that without changing the limits. Right?
Yeah,
Oh,
so
that way, yeah. No, I guess I'm
if you kept it as 0 and 2,
Yeah.
you do the whole thing and then you put the u back in here, 4 minus x squared, then you put in 0 and 2. You get the same answer. So that's the area. Okay, part B. It is known that for y equals this, dy dx equals that. Look at that. They even give you the derivative for it, right? Saving us some time. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. Find the value of C for this spinning toy. Okay, let's think about that. So we took that shape, we revolved it. Now we have a 3D shape in that image. And, so it says the largest cross-sectional circular slice. Where would the largest circular slice be? Right over there, right? And it says that the radius over there, the largest radius is 1.2. Okay? Now, forget about 1.2, forget about numbers. How can we represent that distance from the x-axis to the graph? What is that? That's the right, which is the y value. Okay? That's the y value. Where is this happening? And where is this? What is significant about this point on the graph? If it's the largest distance, which is, it starts with an M. It's the it is magical. The whole thing is magical, but it's also the maximum of this graph, right? This is the maximum value of this graph. If it's the largest, this is happening at the maximum. So how do you find maximum of a function? What do? You set the derivative equal to 0, and look, these nice people, they actually gave us the derivative to set equal to 0. Okay, so largest cross-sectional radius happens at the maximum. That was the tricky part. Now that you know that that's the maximum, you're like, okay, let's figure out where the maximum is. Okay, so this is part B. So to find the maximum, you set dy dx is equal to 0. So that c4 minus 2x squared over the square root, oh my God, equal to 0. Okay, so that's going to be c times 4 minus 2x squared equal to 0. So 2x squared is equal to 4. X is plus or minus root 2. But since it's in the first quadrant, it's just positive root 2. Okay. What is it that we want here? We want the value of c. Okay, but we're given that at that point c, y is equal to 1.2. So you plug it in. So y of root 2 is equal to c times root 2 times the square root of 4 minus 2. And that's equal to 1.2. Equals c times root 2 times root 2. So 1.2 equals 2c. C is equal to 0.6. Whew. Mic drop over there. Mic drop moment. And, no pun intended, but this problem, when it was, when students took the AP test last year, this one really took people for a spin. And everybody was like, oh my God, that one problem. And, is it a tricky one? Yeah, it's a tricky one. There's always one that sort of looks like it came out of left field. But when you really think about it, is it really an unreasonable thing for them to ask you to do? No. No.
A little bit.
Okay, so next, part C. For the spinning, for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? This time we need the volume. Okay, so we can find volume, right? Because volume is what? Pi r squared, right? So pi f of x squared dx. I'm going to work here for this one. So for part C, the volume is pi from 0 to 2, f of x squared dx. So cx 4 minus x squared dx. Okay? And we are told that the volume here is how much? What did we say it was? 2 pi. So 2 pi is equal to pi times the integral from 0 to 2, c squared x squared 4 minus x squared.
Gotta write all that out.
Yeah, you do, because this is the non-calculator part. Yep. Pi's cancel. So 2 is the integral from 0 to 2. So let's distribute. 4c squared x squared minus c squared x to the 4 dx. And now we can integrate this. So 2 is 4c squared x cubed over 3 minus c squared x to the 5 over 5 from 0 to 2. Yeah? Let's plug it in. 4c squared, 8 over 3, minus c squared, 32 over 5. So here's what I would do. 2 is c squared times what is this? 32 over 3 minus 32 over 5. Huh? No. It's 4c squared. It was always a 4.
4c squared minus c squared. How is that just c squared?
No, but it's 4c squared times x cubed over 3. I found out the c squared here.
Oh,
Yeah. And then I multiplied the 4 and the 8. So,
It's a constant, you don't integrate it.
I was about to say, yeah.
right.
it's a constant.
So this is, I believe, 64 over 15, right? I think so. Okay, so c squared is 15 over 32. So c is root 15 over 32. And that's good enough.
Are they not thinking about having the root as a denominator?
Oh, no. No, no.
It's just a
Can you